G'day viewers, welcome to Introduction to Azure Arc Enabled Kubernetes. My name is Onpremises. I'm a Principal Hybrid Cloud Advocate at Microsoft, and joining me today is Vinicius. Mate, how do I pronounce your name and what do you do?
Hello folks, my name is Vinicius Apolinario. I don't have an Australian accent as Orin do, but I'm also a cloud advocate at Microsoft. And it's a pleasure to be here with you guys today.
Cool. Okay, so as you can see on the screen, we're doing a Learn Live module. Now, what a Learn Live module is it's a sort of a PowerPointed up presentation abstraction of a Microsoft Learn module. And if you want to right now or after the presentation, go and actually take the module that this presentation is based on. You can look at that QR code and click it with your device, or you can go and use that URL. Okay, so we can move across to the next slide, which will give you exactly the same information. Basically, again, and this is just giving you a look in the in the web interface of what a module looks like. And you're probably fairly familiar with what Microsoft Learn is at this point. Anyway, in this session, Vinicius and I are going to go through the following topics. Vinicius will start by talking about what Kubernetes is, what Azure Arc is, and what Azure Arc enabled Kubernetes is.
Yeah, and then we move to Orin talking about how you connect that Azure Arc to your Kubernetes cluster running whatever that cluster is.
And then Vinicius will come back and talk about managing Azure Arc enabled Kubernetes clusters using GitOps.
Right, and then Orin takes us away by talking about how to integrate with Azure services like Azure Monitor and Azure Policy.
Now, we do have a chat session that's going on in the background as Vinicius and I are presenting. And there's some really smart, really intelligent, very witty and very articulate moderators in that chat who are there to answer your questions. Or if, 10 hours from now, tomorrow, next week, you sit there and you think to yourself, I've got a question that I want to ask those blokes about what they were talking about. Feel free to contact Vinicius and I, because our contact information will be provided throughout the session, or you can just look at the build webpage and figure out how to contact us from there. Anyway, Vinicius, let's get into it. Let's have a great session.
All right, so let's talk about the first part of the module that covers what are Kubernetes and Azure Arc. So let's take a step back and look at containerization first, because Kubernetes run containerized workloads. So what are containerized workloads? So instead of talking to you about the specifics of containers, let me tell you one thing. Containers, they do solve one specific and very common problem in the IT industry, which is when you move an application from development to test to production, usually there are breaks that happen because the application needs some requirements, some prerequisites, and those are not usually packed with the application. Well, that's what containers do, and that's the problem that they solve in the IT industry. So containers that have multiple other benefits, like they start faster, they are simple to manage, and everything else, but that's the main goal of containers. Now, with the sprawl of containers, you have now containers coming and going, you have containers spinning up everywhere. Just like VMs, you actually need something to go and orchestrate how your containers operate, right? So that's where Kubernetes comes in. Kubernetes is...
before we get to
all right, let's take some questions from Orin.
Yeah, so before we get to Kubernetes, give me an example of, you said that we can sort of pack it into this thing. And if I'm coming from VMworld, where I've always deployed applications in VMs, can you give me an example of something that's really good, a really good type of application to containerize? and maybe something that would be absolutely terrible to try and containerize.
Yeah, of course. So let's start with the good ones first. So developers are developing what we call today as microservices applications, right? So what that means is instead of putting all the components necessary for your application in one single package, you put them in separate packages. And containers are great for those types of architecture because they are smaller, they are faster to deploy, they are faster to start. You can recycle containers very quickly because usually don't have any ties between the container and the host itself or anything in the application. Things like web applications, scheduled tasks, and many others that are usually under this concept of microservices, they fit very well in containers. Things that don't work very well are usually things that you have tied between the application and the host where the application runs. Think about identity services like Active Directory, for example. Those are usually not good fit for containers. Although specifically for Active Directory, if your application does need Active Directory domain joined, we do have a solution for that called GMSA, but that's not the point. Things like file server, where you need very extreme IOPS between the compute instance and the storage device, that's probably not a good fit for a container, right?
Cool. That actually helps me understand that a lot, and hopefully helps you in the audience understand it as well.
Of course. So we have some more questions from Orin coming up later. So let's talk about Kubernetes, right? Kubernetes then is a container orchestrator. So is a extensible Linux-based open source platform for orchestrating containerized workloads. What does that mean? Let me tell you the main benefit of Kubernetes that I think is something that you can benefit from. Kubernetes, you can declaratively say what is the configuration of your application and the configuration of your cluster. What that means is you declare the configuration of your application. For example, my application needs a front end, it needs a back end, it needs a database. Here's how the network is going to work. Here's the connectivity that you have for the load balancer. Here are the ports you need to open. So you declare that in a file, and then you give that to Kubernetes. Kubernetes is going to apply that configuration and do its best to deliver the end result, which is the configuration that you passed on in that file. Everything else is managed by Kubernetes. So where does the pod go? Or the pod meaning the container that actually your application resides. What host does that pod go? How do I manage the load balance behind that? How do I know that the pod is alive and I need to bring another pod up? That's what the orchestration of Kubernetes does for you. It orchestrates the infrastructure for you.
So Vinicius, I've got another question. On the previous slide, you had there that it was an extensible Linux-based open source platform.
Yes.
Now, as someone who comes from Windows world, my first thought was Linux-based. Does that mean that this is only going to work with Windows? And then I had a second question, which was, you're talking about pods, you're talking about containers, you're talking about nodes. What is the difference between all of these?
Yeah. So to your first question, it's not Linux only. The configuration of Kubernetes itself is Linux based. So you're always going to have at least one Linux node to have your Kubernetes environment up and running. However, the nodes or the container hosts that your application can go and run, they can be Linux-based for Linux applications, or they can be Windows-based for Windows applications. So that takes us to the second question, which is what are nodes, what are pods, and what are containers, right? So if you're familiar with VM, you know that a VM runs on a VM host, right? That's a similar analogy for your containers and for Kubernetes. You have a container, which is your compute instance. And in Kubernetes, that reflects usually in a one-to-one for a pod. So a pod is usually referenced as a container, right? Or vice versa. A pod can have more than one container. That's just a detail. But it's usually a one-to-one map. And then that pod runs on top of a container host, which in the Kubernetes case, we call it as a node, right?
Cool. That helps me understand that and probably helps people out in the audience understand that as well.
Great. So let's take that aside for a moment and let's talk about Azure Arc. So if you work in IT, chances are that you're not just running your environment on premises, right? You have VMs, you have databases running on premises, but you might have VMs running in the cloud as well. You might have databases running in the cloud. You might have PaaS services running in the cloud. And the thing is, all of those resources are spread across those multiple environments. So wouldn't it be nice if you could have a single location where you could see your resources, apply configurations, deploy applications from, ensure that the security is okay, ensure that the monitoring of your application that might span on premises and the cloud is made through one single location? So if you are looking for something like that, that's where Azure Arc comes in. Azure Arc is a way to bring every single instance that you might have in terms of servers, databases, Kubernetes cluster, and so on. And we're going to talk about the resources that you can use with Azure Arc into Azure. So you see those resources as Azure resources, even though they don't reside in the Azure cloud, right? So what are the resources that Azure Arc can go and manage? You can manage Azure Arc enabled servers. So that can be a Windows or a Linux virtual machine. It can be a Windows or Linux physical server. You have Azure Arc enabled SQL Server for SQL databases that can reside in other clouds on premises. You have Azure Arc enabled Kubernetes for Kubernetes clusters, whatever they might reside. And even for that, you can have AKS, which is Azure Kubernetes Services, on premises running on top of Azure Stack HCI, and use Azure Arc to manage that Kubernetes cluster. In fact, our demos today, they are based on that specific environment. But you can also have Azure Stack HCI. You can have Azure Arc enabled data services for managed data services. One point that is usually not very clear as well is you can even mix some of that configuration. For example, you can have Azure Arc enabled Kubernetes for your Kubernetes cluster, so Azure Arc can see your cluster as one thing. However, remember we talked about nodes? Well, guess what? You can use Azure Arc enabled servers to manage those specific servers because those nodes are still servers, right? So you can manage those servers as single instances within Azure. So what are the key benefits here? Well, as I mentioned, one of the main benefits of Azure Arc is that you can now group your resources that reside, wherever they reside, on premises, other clouds, or even in Azure, as one thing, and you can apply policy. You can have a single comprehensive inventory of those resources. You can use the Azure portal, the Azure CLI, Azure PowerShell, or even REST APIs to go and manage those resources. So if you want to apply some configuration using another application, you can do that because that other application might talk to Azure using the REST APIs. So you can go ahead and do that. And the other thing is RBAC, which is resource-based access control. So if you want to have levels of access for different people in your organization, you can have that applied to those resources wherever they reside. Log Analytics and other services like Azure Monitor, they can also work for your resources even though they don't live in the Azure cloud.
Okay, so now we're going to talk about what the architectural components are of Azure Arc enabled Kubernetes. Next slide. So here we've got a bit of a diagram. And what we're talking about here is you can see partially here we've got an on-premises location, and then we've got an Azure location. Now, and Vinicius has sort of given us a really good sort of introduction and a sort of high-level overview of what the benefit of Azure Arc is and what's going on with Azure Arc. But when you're thinking about Azure Arc in terms specifically of Kubernetes, you're almost thinking about it in terms of a control plane where you've got all of the dashboards and all of the monitoring and all of the configuration information sitting up there in the Azure portal, irrespective of where you're Azure Arc-enabled Kubernetes cluster is. It could be on-prem, it could be in someone else's cloud, wherever. But the idea here, and one of the interesting and challenging things about managing all of this complex infrastructure around the world, is how do I have a single pane of glass? How do I have a single point of view? How do I have a comprehensible way of understanding all of these resources? And that's one of the things that Azure Arc brings to this. So when you go and connect Azure Arc to your Kubernetes cluster, what it does is it creates a management channel, a bidirectional channel between wherever it is down here and the management plane that exists up there. So it's not just like a VPN connection, because you might not have a VPN installed. But what it does is it communicates. It doesn't require you to open a firewall port on your external firewall so some comes down. Instead, what it's doing is it's connecting that cloud-based management plane right down to your Azure Arc-enabled Kubernetes server. Okay, so let's move to the next slide. So what does Azure Arc enable you to do with Kubernetes? Well, first thing it does is it maintains that authenticated encrypted connection between Azure and your synchronized cluster. And first thing it does is it's getting all of that cluster metadata and synchronizing that up with the Azure resource. So you can see all of the information about what that cluster is. You don't need to go down to the cluster, connect to the cluster, go into the cluster to understand what's going on in the cluster, because you are seeing all of that information sitting there in the Azure portal. So it goes and grabs all that data. It figures out what's the version of the cluster, how many nodes are here, and what version of the Azure Arc agent is there. And then the other thing that goes on is it goes and looks after that administrivia of looking at, is the agent running the current version? Is this cluster in a compliant state? And we'll talk a little later about what we mean by a compliant state. But the easiest way of thinking about it is this configured the way I want it to be configured? Or is one of these settings a bit wrong? It will look at your source control configuration, and then we'll talk about how that works as well, where you can have something in Git affecting the configuration of your cluster somewhere else in the world. And then the other thing it looks after is it looks after orchestrating all of those little bits and pieces that run under the umbrella of Azure Arc to make sure that they work together. Because when you understand what Azure Arc offers, what you're seeing stuff like monitoring, you're seeing stuff like backup, you're seeing stuff like policy compliance. And what it's doing is it's making sure all of those bits and pieces work together. Because as you know, if you've got an IT ops background, is that you might sit there and you go, well, I can add this to this, to this, to this, to this, and I can get it doing all this stuff I want it to do. But sometimes these things interrupt one another and they create a horrible mess. So Azure Arc makes sure that all of these different dancers on the dance floor that are dancing to their own beat aren't crashing into one another and causing a gigantic accident. Next slide. So what are the benefits of Azure Arc-enabled Kubernetes specifically? Because obviously, if you're in like Flynn with Kubernetes, you know what the benefits of Kubernetes are. You know, why would I want to go and plug this extra thing in? Well, what it does is it has enhanced support for automated updates, which means all of your automated updates are going to happen if you've got them using GitOps, where you're setting the configuration. And again, we're going to do a demo of this later on. We also have the way of integrating this GitOps technology with Azure policy that allows you to monitor how that configuration goes. Next slide. You can go and enforce runtime policies affecting the cluster. Now, a runtime policy affecting the cluster is how you can control what executes on that Azure Arc enabled Kubernetes cluster. You might have certain types of workloads that you don't want running, and you can use that management plane from the top down to say, no, bad container, you can't, or bad pod, you can't go and run here. It provides you with a centralized resource for policy compliance. I mean, imagine you've got a Kubernetes cluster out over in Perth. You've got one in Auckland. You've got one running in someone else's cloud, and you've got one running in Azerbaijan, right? But what you can do with Azure Arc-enabled Kubernetes is you can have a single place to go and look at whether or not those clusters are policy compliant. You've also got, and we'll talk about later, Azure Monitor for containers. Next slide. So Vinicius.
All right, so let's talk about how to connect your Kubernetes cluster to Azure Arc, right? So we'll talk about with the prerequisites. Let's start with what you need to have in place in order for Azure Arc to be able to discover and register your your Kubernetes cluster. So first of all, as you can expect, you need a existing Kubernetes cluster, right? You need a user account in that Kubernetes cluster that has at least the cluster admin role. So that has the necessary permissions to create all the components in the Kubernetes cluster for Azure Arc to go. You need an outbound connectivity. In our documentation page, we have details about domains and ports that need to be open. Most of those ports are just HTTPS 443 port. From the other side, from Azure, what you need, of course, a subscription, and you need a Azure user account that has access to that subscription in the Azure Active Directory tenant. And you need the specific permissions in there. We have the documentation on what those permissions are if you are configuring this. Helm 3, so let's pause here and explain what Helm is. Remember that I talked about containers, and containers are a way to package your application along with the prerequisites. Well, Helm is a way for you to package not only the container, but other components that might be necessary for Kubernetes for a multi-container application to go and work. So you create what we call Helm charts that describe multiple containers and components for your application to work, and you deploy a single Helm chart instead of deploying multiple containers. A Helm chart is needed, so you need to install that in your cluster. And as a best practices, it's usually good to go and update your Azure CLI or Azure PowerShell and any other extension that you might be using within your Kubernetes cluster or your Azure environment. However, I don't know about you, but I'm a very visual person. So here's what we're going to do. We're going to do a demo to show how to connect that. A few caveats before I show the demo itself. So first of all, when you're configuring something like this that requires connectivity to the internet and also registering something with Azure that goes down to on-premises and configure that, it takes a while. So we removed all of that by recording a video for you. The second thing is, remember that I mentioned that our demo is based on an AKS or Azure Kubernetes-Service on Azure Stack HCI. Well, Azure Stack HCI or the AKS on Azure Stack HCI encapsulates some of the configuration that you might be doing with multiple configurations with the Azure CLI within one configuration specifically for AKS on Azure Stack HCI. So we're going to do 3 demos today. I'm going to show 3 ways to configure Azure Arc. One, you can do this easily using AKS HCI. So a bunch of those things are already packaged for you. You can do this using the Azure CLI, and I'm going to show you that in the second demo. Or you can use the Azure portal, and I'm going to show you that in the third demo today. So with that, let's go to the first demo. So here we are in Windows Admin Center, where I can configure my Azure Kubernetes service on Azure Stack HCI. You can see that this is all pre-configured. And I also have a target cluster, which is where my applications are going to run. And this cluster has a Windows node pool and the Linux node pool. Remember that we mentioned that you can have that. And Azure Arc is not configured. So I'm going to go to PowerShell now. And here's what I'm going to show you. Hopefully the Learn Live icon. Yeah, thank you. I'm going to use the Enable AKS HCI Arc connection using the name of my cluster to say, go to Azure, to my subscription, and register this cluster to the existing resource group that I have in Azure that my AKS HCI is already pre-configured. So with a simple PowerShell command, now I can go back to my Windows Admin Center, and you see that the Azure Arc configuration is already in place. If I go to the Azure portal, I can go to my resource group. You can see that the VNAP cluster is already there. And all the metadata that Oren mentioned earlier is already here because it's already synchronizing the configuration of my Kubernetes cluster to this Azure portal. The other thing that you can look into is what are the components that were deployed. I think the video played too fast in there. So let me just go back real quick and pause so you can see what I mean. There you go. Hopefully this is paused for you. You can see that many of the components that are needed for my Kubernetes cluster to be registered with Azure Arc are now up and running. So I'm looking at the deployments and the pods. Remember, the pod, they correspond to a container. So these are the necessary components for Azure Arc to talk to this specific Kubernetes cluster. And let's go back to the slides now. Thank you. So hopefully that gives you an idea on how easy it is to onboard an existing Kubernetes cluster into Azure Arc. Next, Oren.
Yeah, and it was really, and this is one of the things, one of the things that Microsoft has always been able to bring to a lot of these complex things is that it's so often we are able to build technologies that simplify taking what can be a very complex and administratively intensive task, and we can abstract it to the point where that task becomes a lot easier to do. So in this case, we're taking existing open source technologies and standards, and we're finding a way to simplify the process of allowing you to manage those things, because the technologies exist, but doing it all over the place in all of these different locations can be a bit of a challenge. Anyway, now what I want to talk about is integrating Azure Arc-enabled Kubernetes with cluster with Azure policy for Kubernetes. So, as we know, and as we talked about, Azure Arc centralizes and streamlines managing a whole lot of stuff, generally outside the cloud, but providing that consistent cloud management experience. Because one of the things that if you use the cloud is that there's all of these different services already that you've got a sort of, and I'm sorry to use the word paradigm, but I sort of have to use it here. It provides you with a consistent management paradigm for managing a disparate set of resources. And where Azure Arc extends this, where Azure Arc helps you in a hybrid environment, is it provides you with that consistent management paradigm for a disparate set of resources that exist outside your cloud environment. So that once you understand how to manage it all here, once you understand the language, once you understand the structure of how to understand what is going on, because that's a big part of systems administration, is I need to understand what's going on with my stuff. And if I don't understand what's going on with my stuff, how can I manage it? And Azure Arc allows you to have that consistent management experience. Next slide. So let's talk about policy. So Azure policy, the whole idea of Azure policy is, first, I have this configuration I want these resources to be in. And are they in that configuration? And then what can I do about it? So the way that policy works is you basically set up what policies you want, and then it goes out and checks to see whether or not those resources are compliant with the way that you want it to look. And you can see on this particular screenshot here that some of the policies that we're looking at actually are based on cloud security compliance accreditation standards. So it's not just, oh, have I correctly tagged my resources? But it might be, okay, we've got the National Institute for Supercomputer Technology, NIST standard, security standard, is this security standard being enforced? Is this ISO 27001, which is a cloud computing security standard, actually being applied in the right way? And anybody who's done compliance standards or compliance audits knows that up until a certain point in time, you'd have to bring in a third-party consultant who'd run their own tools to go and check whether or not you are compliant with the standard. And there might be some arguing about whether or not that was an accurate check, because the standards themselves are open to some level of interpretation. With something like Azure Policy, you have a dedicated team at Microsoft who has studied these standards to the point of absurdity, to understand how can we actually perform checks to determine whether or not a specific compute workload in a specific category is actually compliant with those standards. So you can perform a good degree of your compliance audits to determine whether or not you are compliant with particular security standards. And there is many, because each country has their own standards, each geographic region. So the EU has different standards from the United States, who have different standards from Australia. And you can go and look at your resources and determine if they're compliant. And that's very important, because when we start as developers developing an application, we just want the thing to work. But there's this whole extra layer. It's almost like what I'm going to call the policy layer, that's there to allow you to determine whether or not it's running in a way that's actually legal and compliant with whatever country or jurisdiction you're in's regulations. So that's the first part of policy, is checking the configuration. Now, the next part of policy is the ability in some cases to remediate it. Now, there are some things you can easily remediate, and there's some things that you're going to have to go and do by hand. But at least with policy, you are aware of where you are non-compliant, and you can start to figure out a way of bringing your resources into compliance. So when we're thinking about it, as we will be in terms of Kubernetes clusters, we're starting to think about, okay, we've got this thing. Is it running in the way that we want? Is it running in the way that we want purely from an operations perspective in terms of the configuration? And then later on, okay, we've got the thing working. Is it actually running in a fully legally regulatory appropriate manner as well? Okay, so next slide. So what's Azure policy for Kubernetes? Well, we've got Azure policy for VMs. We know what a VM needs to look like. Azure policy for Kubernetes, like it says on the tin, is a way of having a set of policy definitions that are appropriate to Kubernetes. So what you do, and we'll talk about how you set it up, is that you can then take a set of pre-built policies that have been done by Microsoft that are appropriate to this kind of workload. And then what you can do is you can use those pre-built policies when you've connected it all up using Azure Arc to go and check whether or not your Kubernetes clusters, wherever they are, when they're Azure Arc enabled, are actually compliant with that set of policies. So it will go and check, what are your policy assignments? And you set them up here in Azure and you say, this is what I want you to go and check for. Go and have a look at that thing and see whether or not it's compliant. And then it goes and pushes those down, and then it deploys those policy definitions into the cluster as resources that in some cases might apply constraints. Because with policies, you can have policies in an audit mode where you say, I want to know if this thing is not compliant. And then you can actually turn a policy on in application mode where you say, I am going to restrict anything new from happening that is not compliant with this policy. So a simple version of that might be if someone tries to deploy a pod that isn't appropriately tagged with metadata. And if they haven't done that, it'll block them and say, oi, go back, put your right tag on this workload, and then you can go and deploy it. Or it might be that you can only deploy a certain type of workload in a certain type of region, so that you can block people from violating policies as opposed to sort of detecting that the violation has occurred and then having to remediate it after the fact. Next slide. So, Azure policy for Kubernetes. It reports auditing compliance data to Azure policy. It allows you to go into the Azure portal and review the Kubernetes status. Now, it supports Azure Kubernetes services, including AKS deployment on Azure Stack HCI. Azure Stack HCI is Microsoft's special on-prem hyper-converged Azure fully connected box that sort of lets you run Azure workloads on-prem, but one of the things it allows you to do is have a fully hyper-converged environment where most of the stuff's done for you through an Azure portal, or you can even manage it from Azure, where it can do it on-prem. And then you've got Azure Arc enabled Kubernetes, and that might be a Linux cluster that you've configured all of the small bits and pieces running on Linux systems, running Red Hat or Ubuntu or whatever that's got Kubernetes running, and you've installed the appropriate Azure Arc agent so it's reporting up to Azure. Or if you're running it on AKS Engine. But what it means is you can see all of these different flavors of Kubernetes can be utilized or can leverage Azure policy. Next slide.
I have a question that actually the audience might be thinking, which is, you talked about creating those policies and how experts can come in and actually say what those checks are. If I'm not familiar with Azure policy, and actually if I'm not into auditing at all, do I have to create those, or does Microsoft provide some of those checks for me by default, and then I can add some custom ones?
So the way that it works, great question, is that there is a bunch of policies in the tin already. So you can select from a bunch that Microsoft has already created. But where it gets cool is that there is a big community of MVPs and RDs who have then gone and created their own policies. So you can start with the ones that Microsoft provided. You can go out and find community created ones. And then once you're at a level of expertise and once you understand what you're actually looking for, you can go and author them yourself. So my recommendation is that you first go and review what Microsoft provides. And if that meets your needs, fantastic. If it doesn't, then go out and have a look, because chances are what your needs aren't particularly unique to you. There's probably someone else out there in the great wide world who has solved the problem that you have. So, and they've probably shared that solution. So go out to the community, go and see if the community solved that problem. And if you go, well, Microsoft hasn't solved it, the community hasn't solved it, I'm going to go and solve it, you can go and solve it, and then maybe you, as one of those productive members of the community, solve the problem and then go and share your solution so that others can benefit from the work that you've done and the problem-solving skills that you've applied.
That's great.
Okay, so how to implement Azure policy for Kubernetes? Well, the first thing you need to do is you need to get the Azure policy for Kubernetes add-on, and you can do that through the Azure portal. You need an Azure Arc-enabled Kubernetes cluster. So Vinicius has shown you how to go and take an Azure a Kubernetes cluster and make it Azure Arc-enabled. Okay, so you need the appropriately permissioned accounts. You need one user account that has cluster admin role on that cluster. You need an account in Azure that has the access to the subscription that hosts the Kubernetes resource, and this account does need permissions to create service principals. So remember the properties of role-based access control, which is your limit what something can go and do. Next slide, please. Okay, so how to implement the policy? Well, you start a CLI session, you sign into Azure AD, you register the policy resource provider. You'll only need to do that once. You grant a specific right here, which is policy insights data data writer, and that says preview, but it'll be GA. You install the policy add-on using its specific Helm chart, and Vinicius covered what a Helm chart was. And then you create the policy assignments that go out and check the things that you want to check. Next slide. So Vinicius is going to do a demo showing how to actually do this.
All right, let's do this. Before we get into the demo itself, remember that I mentioned that there are 3 ways for you to configure Azure Arc stuff. One is if you have an AKS HCI cluster, you can use the native AKS HCI PowerShell commandlets. You can use the regular Azure Arc commandlets because that's for any generic Kubernetes cluster. And then you can use the Azure portal. We're going to use the second mode now, where I'm going to use PowerShell and use the Azure CLI to do that. The Azure CLI uses an extension for the Azure CLI itself that basically says, Azure CLI, you don't know how to talk to my on-premises or whatever other cloud cluster is, right? So I'm going to use this extension to help you read my kubeconfig file. If you're not familiar with the kubeconfig file is the configuration of how to talk to your Kubernetes cluster that resides in your home folder. So basically what this extension does is, look, Azure CLI, this is how you find the kubectl file, and here is the connection that you need to talk to. So when you apply a configuration, this is the target cluster that you need to talk to. So with that said, let's take a look at the demo. All right, so here we are again in Windows Admin Center. It's the same cluster that we used before. So it's the VNAP cluster. That's the cluster that my applications go to. I have a Linux and a Windows node, and this is already configured with Azure Arc because we did that before. So with that said, let's take a look at the PowerShell. I'm going to ask for the Learn Live icon to be removed so we can see the command there. So you see the Azure CLI command, which is the Kubernetes extension create. And we are going to talk to the connected cluster. Remember that we're talking to the kubeconfig file. The cluster name, which is the VNAP cluster, needs to match to your configuration. What is the resource group I want to use? And this is the policy that Ori mentioned before, and the name of the policy that is going to be created. So the command ran fine in my case. Everything succeeded. So I can go and take a look in the Azure portal now. So now at the Azure portal, I can go and look at the resource group, my cluster, just the way I showed before. But notice now that the extensions with the name Azure Policy is now showing up. So I can click the policies on the left. You can see that this is enabled. However, you see the configuration for Azure Policy in the Azure Policy dashboard itself. I have a default policy here, and you can see that the compliance state is showing as non-compliant. So as Orion will say, oi, let's take a look at what's going on here. You can see that all those policies that Orion mentioned that are pre-configured for you, they all ran against my cluster. That are endpoint connectivity, privileged identity. The one we're looking at here are the ones that are non-compliant about logging and threat detection. So let's take a look at this first one. And basically what it tells me is it was expecting the Azure Defender for Cloud was enabled, and it's not. So you might be missing some of the security configuration that Azure Defender for Cloud might be checking for your cluster. And the VNAP cluster, for that reason, is non-compliant. All right, back to you. Oh, actually, I should say back to the slides because it's back to me. So hopefully that gives you an idea on how Azure Policy works. So you can understand now that basically we're talking about Azure Arc connecting to your cluster, and then Azure services coming on top of that and applying the regular configuration as they would for an Azure resource. But in this case, because of Azure Arc, they can do that for external resources like an AKS HCI cluster. So with that, let's dive into GitOps. So first of all, what is GitOps anyway? So GitOps is a DevOps practice that relies on Git repos or repositories to host files that contain the configuration representing the expected state of a resource. So let's drill down into what that means. Let's say you have a GitHub repo or a repository that contains either a configuration for a Kubernetes cluster or even the deployment of your application itself. instead of manually going to your Kubernetes cluster and deploying like you would in the old ways of running VMs, probably what you want to do is adopt some DevOps practices like a CI/CD pipeline. And then what you can do is say, my Kubernetes cluster, look at that repo and deploy the configuration that is in there. And by the way, if something happens or changes in that repo, I want to automatically apply that configuration to my Kubernetes cluster again, either to deploy a new version of an application or to maintain my Kubernetes cluster configuration up to the standard that I need it to be, right? So how do we configure that? So basically what we do, as I just described, is we need a GitHub repository where you have the configuration for your Kubernetes cluster or the deployment of your application. And then what you are going to do is you are going to use a open source plugin called Flux that basically explains to Azure Arc how to go to that GitHub repo and bring that configuration to your Kubernetes cluster. Like I said, I'm a very visual person. I think there's a lot of questions coming at this point on how exactly does that work. So let's take a look at a demo and see how it all what it all means. So let's take a look at our final demo now. Again, I'm back at Windows Admin Center. This is my AKS on HCI cluster. The VNAP cluster is the cluster that we're targeting here for the applications. I have a Linux and a Windows node pool, as I mentioned before. And as we've seen before, this is already connected to Azure Arc. So now let's use the Azure portal to configure GitOps. So I'm going to navigate to my cluster under the resource group. You can see that the policy was already configured. So now what I'm going to do is on the left-hand side, I'm going to click GitOps. And I don't have anything configured. And the Flux version, there's two versions here. I'm going to use the version 1 just for the simplicity of that version. But if you need something specific, you can use the version 2 as well. The configuration name is basically how this configuration will be seen as an Azure resource itself. So I'm going to call it the vnap-vault-app-config. I'm going to talk about the application in a second. The instance name, which is what are the name of the instance inside of your Kubernetes cluster so you can find it later, as well as the namespace that basically is the boundaries that you want to put in this application. The GitHub repo you're looking at is my application. I'm going to come back to that in a second. Basically, what I need now is the URL for that repo. It's a public repo. I'm hosting that on my GitHub. You can check it later. And I'm going to click Add. So basically what it does, it saves that configuration here on GitOps under the Azure portal. So I'm going to refresh that page, and you can see that the configuration is in there. And the operator state, which is the main thing I'm looking at here, is showing as pending because this is being applied to my Kubernetes cluster. While that works, let's take a look at the application. So this is a very basic application on GitHub. And that application has a YAML file. So remember that I said every application that is deployed to Kubernetes is deployed via a declarative form. So YAML files are a way for you to do that. And what you're seeing here are blocks of code that describe part of what needs to be deployed to Kubernetes. The first part, as you can see at the top, is deployment of my application. You can see that I have here an image name for a Redis cache, which is my database in this case, that is going to compute the votes on my application. And the service, which is the next a block of code that you see there, is the networking configuration for that specific backend of my application. If I continue here, you'll see that I have 2 replicas for the backend. If I keep moving forward, I have another deployment, which represents another pod for 2 replicas as well. I have another service, but oops, I'm sorry. I misclicked the configuration here. So let me go back to where I was. I have another deployment for the front end, and I also have 2 replicas for that as well. And I have another service or another networking configuration for a load balancer that goes in front of my front end of my application. So with all that said, I can now go back to my Kubernetes cluster. Let's take a look at using kubectl, which is the command that brings all the configuration or everything for Kubernetes, basically. And I have a new namespace that comprises the configuration of my application. So if I take a look at the pods running under that namespace called Vault-app, you see that I have 2 pods or 2 containers, right? That basically deploy my application now. So if I look at kubectl get pods outside of those namespaces that I looked before, I have 4 pods. And why is that? I have 2 replicas for the front end and 2 replicas for the back end of my application. So those pods that you see in there, the Vault back and Vault front, are exactly the pods that represent my application. If I look at the kubectl get service, you see that I have the networking for the back end, the networking for the front end as a load balancer. So if I take a look at the external IP address, this is my application up and running now. So I can vote on cats, I can vote on dogs, or I can reset the configuration. But more importantly, remember the DevOps practice that we talked about. Now, what I want to do is I want to move from 4 total pods to 6 total pods. I want 3 pods representing my back end and 3 pods representing my front end. So what I'm going to do is I'm going to change the replicas in my YAML file, and I'm not going to touch Kubernetes. I'm just going to touch the YAML file. I'm going to commit those changes to my repository. And if you wait for a while, up to 10 minutes, because that's the default configuration, you'll see that those pods are now a total of 6 pods just because I changed the file in my GitHub repo. And I have a total now of 3 for the backend, 3 for the front end, and all of that applied through the Flux configuration under the Azure Arc for Kubernetes. And if I go back to my application, of course, the application goes, it's working just as it should. So hopefully that gives you an idea on how easy it is to configure GitOps for Azure Arc for Kubernetes. With that, I'm going to pass on to Oren so he can talk about Azure Monitor.
So, and that's an amazing demo for a lot of reasons, because you had some stuff going on in GitHub, you had some stuff going on in Azure, and then you had an on-premises Azure Stack HCI cluster hosting Kubernetes. And the change in here went through there, down there, and into there, and then it just happened like that. And getting all of that glue working is a non-trivial task. Getting all of those things to work together is a non-trivial task. And that's sort of what we're trying to get to when talking to you about this, is saying, look, we're providing these pathways, we're providing these tools that allow you to simplify something that, yes, you can already do, but look at the amount of time and the amount of effort that you can save in doing it by putting in place all of these pathways, these tram lines that actually get something going. Okay, so now I want to talk to you about integrating Azure Arc enabled Kubernetes with Azure Monitor. Next slide. So this is a terrible slide. It's a core component of the Microsoft strategy to extend comprehensive cloud-based management functionality beyond Azure. I was really surprised that the word synergy did not appear there. Empower might have been there, but we probably took it out. Now, what does that mean? Well, let's go to the next slide. What it really means is that it gives you the ability to take Azure Monitor, which is your one-stop shop for looking at how something is working, getting all of that telemetry, and then going and examining it. That's without using words like synergy. So what can you do? Well, Azure Monitor comes with a bunch of dashboards and workbooks. A dashboard is providing you with the information, a workbook's kind of going out and getting it. It gives you the ability to do metrics analysis using Metrics Explorer, or if you want to get really fancy, Power BI, which is basically like what you'd get with Excel, and you gave Excel superpowers. You've got common action groups. What a common action group is, it allows you to have a set of pre-configured alert-based trigger actions and alert recipients. That is, Monitor has seen something that it reckons you need to know, and this is how it's going to let you know about it. You can trigger notifications via text message and email. Now, the thing I always tell people about notifications is don't send yourself a notification or don't set up a notification unless you're willing to respond to it at 2 a.m. Because what we all do with notifications via email is we create an email rule, it goes into a particular folder, and we never look at the folder again, except for to come back to it a couple of months later and look at it and go, gee, there's a lot of alerts there. Right-click, mark as read, or right-click, delete folder. Okay, trigger a remediation action. If you are absolutely confident that you're monitoring the right thing and you know what needs to be done, and you're willing to allow it to do that automatically, and it's not going to turn into a cascading disaster, because some people set up these automatic things like see alert, reboot the machine, and then their machine's rebooting the whole time, and that's probably not the world's best way of solving that problem. You can trigger a remediation action, but please, 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 please test that before you put it in place. Or you can go and do something even more clever, which is delegating the problem to someone else. An alert is raised, and what it does is it goes and puts something in the job tracking system and assigns it to the colleague. So you figure out how to assign all of the problems to Pierre Roman, and Pierre Roman has to go and figure out how to solve those problems because he's sitting there in DevOps. Where did I get all of these jobs from? Did Rick assign these to me? And make sure it looks like Rick assigned them to him. Anyway, moving on to the next slide. Azure Monitor for Containers is a specific set of tools that allows you to monitor what's going on in a container environment. So all of that stuff that we understand about how containers work, it allows you to pull out that telemetry and how to take that telemetry and put it into a meaningful set of dashboards and workbooks and what have you. So think of it as a sort of a plug-in, or if you want to go really back old school and you are using Operations Manager, it's like a management pack for containers. So it will go and do managed kubes clusters on AKS, self-managed Kubernetes clusters. It'll look at container instances. It'll look at self-managed Kubernetes clusters hosted on Azure Stack on-prem. It'll also be able to go and look at Red Hat OpenShift and Azure Arc-enabled Kubernetes, because brand new, spanking new, shiny Microsoft is very good at making sure that we look after all of your things, not only the things that were made over in Seattle. Next slide. So what will it do for containers? It'll identify containers running in individual pods. So you can track the pod's performance from a container level. It'll evaluate resource utilization of workloads running on the host. It'll determine how the cluster looks under normal load and under extreme load, so that when you're looking at it, you can figure out how much stress is this thing under. It might look like it's going the clappers, but what it's actually doing is it's actually operating normally, and that's completely normal. And that sound that the engine is making is completely normal, and you don't need to go and get the car serviced. And you can go and configure alerts to notify you when resource utilization is out of normal bounds. It's doing something unusual, or it's indicating that the state of the cluster has gone into an unhealthy state. Next slide. So how to do it? Well, it uses a containerized version of the log analytics agent. And when you deploy it, the agent runs on the cluster, and it goes and connects to all of that bit of the cluster and then reports all that data up to Azure so you can see it in the appropriate dashboards. Next slide. Now, the requirements. You need a log analytics workspace. You always need one of those. Access to the cluster with a user account that has the cluster admin role. An Azure AD account that has contributor role within the log analytics workspace, and the Azure Arc-enabled Kubernetes resource. You need Helm 3, Azure CLI or PowerShell core, and the resource ID of the Azure Arc-enabled Kubernetes cluster. Next slide. Okay, so we've reached the end of the module, and in this module, Vinicius and I covered the following. We described Kubernetes, Azure Arc, and Azure Arc-enabled Kubernetes. Vinicius.
We talked about how to connect your Kubernetes cluster with Azure Arc.
We talked about how to manage Azure Arc-enabled Kubernetes clusters using GitOps.
and then how to integrate other services like Azure Policy, Azure Monitor, and so on.
We really hope that you've got a lot out of this Learn Live session. We'd absolutely love you to go and take the module. And the other thing that we'd love you to do is make sure after you finish this session that you go and fill your evaluation. Thank you very much for your attention. You can find us wherever you need to find us, and have a wonderful rest of the event.
Thanks everyone for watching. We'll see you next time.